Hi everyone, welcome to the next video of the one-shot series. In this video lecture, we are going to discuss previous year questions of electrochemistry. Let's go in a systematic way to discuss this topic. So first we are going to discuss the weightage of electrochemistry, syllabus, mind maps, and after that we are going to discuss some of the previous year questions. I have already discussed how to use this video. Obviously, first you have to revise the short notes. You have to write down the important information with respect to everything, with respect to all the topics, and then you can start doing the practice along with me. Now, if we talk about the weightage, so generally one question is going to come, right? Every year one question is going to be from the electrochemistry part. What are the high priority topics in this chapter? In this chapter, generally the questions are from the Nernst equations, Faraday's law, and the conductance. So these topics, out of all the topics, are very important topics. Okay. Now let's discuss mind map. Complete electrochemistry is divided into 5 important topics. 5 important topics, they are highlighted in the orange circle. Electrochemical cell, that is the galvanic cell. Conductance, batteries, fuel cell, and electrolysis or electrolytic cell. In electrochemical cell, you all should know the working of the galvanic cell, how to represent the cell, standard hydrogen electrode, concentration cell, electrode potential in terms of standard reduction electrode potential or standard oxidation potential, EMF of the cell. EMF of the cell we can calculate from the Nernst equation. We have to understand the thermodynamics of the cell. In the thermodynamics of the cell, we are going to relate Gibbs free energy with the equilibrium constant. So we have certain formula for that. In electrolytic cell, in electrolysis topic, we have electrolytic cell and we have quantitative aspect of electrolysis. So in the quantitative aspect of electrolysis, we are going to discuss Faraday's first law and Faraday's second law. So we have certain formulas for that. Now we have conductance. So what is conductance? Conductance means ability to conduct electricity, and we all know that electricity can be conducted via 2 ways, either by the motion of the electrons or either by the motion of the ions. If I talk about the electrolytic conductance or ionic conductance, it means that is related with the aqueous solution. So aqueous solution, or we can say electrolytes in water, can conduct electricity because they can dissociate into their ions. So when they dissociate into their ions, so we have the concept of the degree of dissociation. Degree of dissociation. With respect to conductance, we have to understand, you should know the some basic idea about important terms like resistance, conductance, molar conductivity, equivalent conductivity, specific resistance, specific conductance, right? Then after that, you should have the idea about some conductometric titration. We are going to discuss question related to conductometric titration. It's very simple. Okay, it's very simple. So I hope I am clear about what you need to study, what you need to revise before starting with the questions. Now, let's start with the question number 1. So, if you see this question, we have at 298 Kelvin, which is the room temperature, 25 degrees Celsius, a 1 liter solution containing 10 millimole of Cr2O7 and 100 millimole of Cr3 plus, and it shows a pH of 3. So let's write down the information. So pH is equal to 3, it means that is an acidic medium, and we have already discussed in redox that dichromate Cr2O7 2 minus in acidic medium is converted to Cr3 plus. Okay, now first we have to find out the change in electron. So let's find out the change in electron. So by using the X method, this is 2x plus 7, oxidation state of oxygen is minus 2, it is equal to minus 2. So 2x minus 14 is equal to minus 2, 2x is equal to plus 12, and x is equal to plus 6, right? But in order to find out the correct number of electrons which is exchanged during this process, So first we have to balance the chromium. So here we have 2 chromium, so we write 2. So it means we have to take the oxidation number with respect to 2 chromium. So 2x is equal to plus 12 over here. So here x is equal to plus 3 and 2x is equal to plus 6. So it means this is the reduction process, and in this reduction process 6 electrons, or there is the exchange of 6 electrons, right? There is the exchange of 6 electrons. Now this is an acidic medium. So next step, because this is a half cell reaction, so we have to balance accordingly. So we have 7 oxygen, so we have to balance oxygen by adding water molecule to the deficient side, and then we have to balance hydrogen by adding H plus to the deficient side. So this is my half cell reaction, and this is the reaction which occurs at cathode, because this is the reduction reaction. Now what is the next part of this question? So the volume is 1 liter, Cr2O7 minus moles 10 mole. So concentration of Cr2O7 minus number of moles divided by volume. So 10 upon 1, which is 10 millimole. This is 10 millimole, right? This is 10 millimole. So this is 10 into 10 to the power minus 3, right? Or this is going to be the volume is 1 liter. So this is equal to 10 to the power minus 2, 10 to the power minus 2 mole per liter. Okay, now Cr3 plus moles are 100 millimole. 100 millimole. 100 millimole. So let's find out the concentration of Cr3 plus. So number of moles divided by volume. So we can say 100. If I am taking here millimole, so I have to take volume in milliliter. So volume is 1 liter. So in millimeter, it is 1000 ml. So we get 10 to the power minus 1 mole per liter. Is it clear or not? Okay. Now the next step. pH is 3. So if pH is 3, so we can find out the concentration of H plus from here. So pH is minus log of H plus, which is equal to 3. So concentration of H plus is equal to minus antilog of 3, and minus antilog of 3 is equal to 10 to the power minus 3. Antilog 2 is equal to 10 to the power 2 minus antilog 2, it is equal to 10 to the power minus 2. Okay. Now next information, E naught cell is given. E naught cell is given, which is 1.330 volt, and 2.303 RT upon F का value is 0.059. And we have to find out the potential for this half cell. It means E cell we have to find out. And the value of this is x into 10 to the power minus 3. Okay. So this is the question of Nernst equation. So let's solve it. Nernst equation. So if I use Nernst equation, so E cell is equal to E naught cell minus 0.059 upon n. ठीक है, 0.059 upon n log concentration. So in the product side we have Cr3 plus, and reactant side dichromate Cr2O7 minus and 14H plus. So we write concentration of Cr3 plus का square, concentration of Cr2O7 minus, and concentration of H plus to the power 14, because we have to take coefficients into account, right? Up now we have to put the values. So E naught cell is 1.33, it is 1.33, 1.330, right? So 1.33 minus 0.059, n is the number of electron, which is equal to 6 log concentration of chromium 10 to the power minus 1 square, concentration of dichromate 10 to the power minus 2, and concentration of H plus, it is equal to 10 to the power minus 3, and it is 40. So on solving we get 1.33 minus 0.059 upon 6, that is log 10 to the power minus 2, here 10 to the power minus 2 and 10 to the power minus 3 goes in the numerator, and we have the value 10 to the power 3 to the power 40. Cancel 10 to the power minus 2, it cancels, and we have 1.33 minus 0.059 upon 6. Then we know that log a to the power b is equal to b log a. So we can write 14 3s are 42. So we can write 42 log 10. It just now you have to solve the value, right? You have to solve the value and you get the answer as 0.917. You get the answer as 0.917. Okay, on solving. Log 10 is equal to 1. Log 10 is equal to 1. So you get E cell is equal to 0.917. But we have to report the answer in terms of 10 to the power minus 3. So 0.917 can be written as 917 into 10 to the power minus 3. So the value of x is equal to 917. So this is the answer. This is the value that you have to report. Okay. I hope this question is clear. Now let's do the next question. So next question is related to conductometric titration. So just try to understand the conductometric titration question. So choose the correct representation of conductometric titration of benzoic acid versus sodium hydroxide. Benzoic acid is what? C6H5COOH. This is benzoic acid, right? So on reaction with NaOH, what happens? It is a neutralization reaction. It is a neutralization reaction. So in neutralization reaction, we get sodium salt of benzoic acid, or we can say sodium benzoate plus water. Clear? Now what happens? You are adding NaOH in some amount of the benzoic acid. So first what happens? H plus is replaced with Na plus. H plus is replaced with Na plus because acid has tendency to lose H plus, and we are getting Na plus in place of H plus. Clear? So obviously more mass, H plus mass is less. So initially conductance decreases slightly, not too much, slightly. ठीक है? Slightly. Now after that neutralization is going to happen and you are adding more amount of NaOH, then conductance value increases. After that conductance value increases. So the option number 2 is correct. So initial phase में H plus is replaced with Na plus, so that's why conductance value slightly decreases. And then after adding NaOH, because Na plus is a strong electrolyte, so on addition of further NaOH, what happens? Conductance increases. And after the neutralization point, or once neutralization is over, then we have NaOH in the solution. So on further addition of NaOH, conductance value increases too much. So this is how we can understand this conductometric titration. Clear? So option number 2 is the correct answer. Now let's do the next question. The next question is again related to the Nernst equation. Nernst equation is a very important topic. So just try to write everything. What is given in the question. Okay. So then first, if you see this is the anode and this part is the cathode. Okay. Left hand side is anode and right hand side is cathode. So anode, what reaction we are going to write? So we are going to write H2. Okay, H2 gas, right? It is converted to H plus F plus. So here we can write half H2 and one electron is going to remove, right? One electron is going to lose. Now cathode, if we see cathode, so Fe3 plus aqueous is converted to Fe2 plus aqueous. Okay, so now here there is a change of one electron only. Let's add both half cell reaction to write down the complete reaction. So we get half H2 gas plus Fe3 plus aqueous gives Fe2 plus aqueous and H plus aqueous. Okay. Concentration of H plus is 1 molar and pressure of H2, it is 1 atm. And we have to find out the ratio of concentration of Fe2 plus and Fe3 plus. We have to find out what? Ratio of concentration of Fe2 plus and Fe3 plus. Okay. Fe2 plus and Fe3 plus. So let's do it. Fe2 plus. So let's take concentration of Fe2 plus and Fe3 plus as X. Okay. So we have to find out the value of X. Now, for this reaction, let's find out E naught cell. So E naught cell is E naught H2H plus, that is the standard oxidation potential. Then we have salt bridge plus, then E naught Fe3 plus 2Fe2 plus. And this is the standard reduction potential. So standard oxidation potential is 0 and plus 0.771. So E naught cell is 0.771 volt. Okay, E naught cell is 0.771 volt. Now let's apply the Nernst equation. So on applying the Nernst equation, we get E cell is equal to E naught cell minus 0.059 upon N, and that is log. Log में concentration of Fe2 plus H plus, Fe2 plus H plus, then concentration of Fe3 plus and pressure of H2 का power half. Why? Because the coefficient of hydrogen is half. Let's put all the values now. E cell potential of the cell is 0.712. Potential of the cell is 0.712. So see, here we write 0.712. E naught cell is 0.771. Here N ka value is 1 log Fe2 plus upon Fe3 plus. Let's assume it as X into 1, and this is also 1 ka power half. ठीक है. So now on solving, what do we get? 0.712 minus 0.771 is equal to minus 0.059 log X. So on solving, here we get 0.059 minus, then is equal to minus 0.059 log X, and on solving we get log X is equal to 1. So if log X is equal to 1, so X is equal to anti-log of 1. Anti-log of 1 means 10 to the power 1. So answer is 10. So ratio is 10. Fe2 plus concentration and Fe3 plus concentration, it is equal to 10. Okay. Like if I have minus anti-log of 2, so it is 10 to the power minus 2. If I have anti-log of 2, so it is going to be the 10 to the power 2. Okay, 10 to the power 2. Now on the basis of similar note, you can solve this question. I have already solved the full question. Just try on your own and try to find out the correct answer. The correct answer of this question is 3. Completely based on the Nernst equation. Okay, completely based on the Nernst equation. Now let's do the next question. The standard electrode potential M3 plus to M2 plus for vanadium, chromium, manganese and cobalt are this: minus 0.26 volt, minus 0.41 volt, plus 1.7 volt and plus 1.97 volt respectively. So In the question, we have to find out the metal ions which can liberate hydrogen from a dilute acid. So see, if I say dilute acid, so in dilute acid, hydrogen is in H plus, and if we remove hydrogen in form of H2 gas, then what happens during this process? Here oxidation state is +1 and here oxidation state is 0. So this is called reduction. This is called reduction. So the metal has to oxidize itself, right, in order to achieve this process. So it means let's write down the standard oxidation potential for the respective metals. So for standard oxidation potential for V2 plus to V3 plus, it is going to be plus 0.26 volt. Now for Cr2 plus to Cr3 plus, it is going to be 0.41 volt, because reduction potential values are given in the question. We have to convert this into the standard oxidation potential, and we know that standard oxidation potential is minus of standard reduction potential. So we are going to do in that way. Now let's do for Mn2 plus. So Mn2 plus to Mn3 plus, right, we get the value of 1.57 volt, and cobalt 2 plus to cobalt 3 plus, we get the value of minus 1.97 volt. So only for these two metal ions, right, the value is positive. So value is positive means V2 plus and Cr2 plus can oxidize, right, oxidize to V3 plus and Cr3 plus respectively. So we have only these two metals. So answer is going to be option number 3. Answer is going to be option number 3. Okay. Now let's do next question. So the next question is the graph. Following figure shows dependence of molar conductance of two electrolytes on concentration. So if you can see this curve, right? So this is the molar conductivity curve, right? Molar conductivity curve for strong electrolyte and the weak electrolyte. So B curve is for strong electrolyte, and A curve is for weak electrolyte, So for strong electrolyte, we have Debye-Huckel-Onsager equation, and that Debye-Huckel-Onsager equation is lambda m is equal to lambda infinite m, molar conductivity and infinite dilution, plus B under root C, right, plus B under root C. So the point is we can compare this with y is equal to mx plus c. We can compare this with y is equal to mx plus c. So B is for strong electrolyte. Now the number of incorrect statement from the following: lambda not m for electrolyte A is obtained by extrapolation. For A electrolyte, no, we cannot find out the molar conductivity of weak electrolyte at infinite dilution on extrapolation. So this is the incorrect. Now second, for electrolyte B versus lambda m, for electrolyte B, lambda m versus under root C graph is the straight line with the intercept equal to lambda naught m. Yes. Here intercept is what? Here intercept is this. This is lambda m. B under root C, x is under root C, or intercept is lambda infinite m. So this is the S. Now next, at infinite dilution, the value of degree of dissociation approaches to 0 for electrolyte B. No. 0, why 0? On infinite dilution, alpha is 1, or we can say alpha is equal to 100%. Okay, so this is incorrect. So this is incorrect. Now last statement. Lambda naught m for any electrolyte A and B can be calculated using lambda naught for individual ions. Yes, that is as per the Kohlraasch law of independent migration of ions. called Rash law of independent migration of ions, right? So how many incorrect statement out of the following? So we have total of 2 incorrect statement. The answer is 2. Now let's do next question. So next question, the equilibrium constant for the reaction. The reaction is zinc solid plus Sn2 plus aqueous. It gives Zn2 plus aqueous plus tin solid. So let's write down, right? Write down the reaction. So anode, on anode oxidation happens, right? So we can write zinc solid gives Zn2 plus aqueous plus 2 electron. Now cathode, on cathode reduction happens. So if reduction happens, so we can write Sn2 plus aqueous. It gives Sn solid plus we have to write 2 electron. Now let's write down the final reaction or the complete reaction. So on writing the complete reaction, we get zinc solid Sn2 plus aqueous gives tin solid and Zn2 plus aqueous. Okay, fine. So the magnitude of standard electrode potential for Sn to Sn2 plus we have to find. Okay, so we have to find E naught of Sn and Sn2 plus. So this is the standard oxidation potential. Equilibrium constant is given, so it means we have to consider reaction at equilibrium. So if reaction is at equilibrium, so we can say delta G is equal to 0. Delta G is equal to 0, right? Delta G is equal to 0. So if delta G is equal to 0, so we know that delta G is equal to delta G naught plus 2.303 RT log K equilibrium. So delta G is 0. So delta G naught is equal to minus 2.303 RT log K equilibrium. Also we know this that delta G naught is equal to minus NF E naught cell. Okay, minus NF E naught cell. So let's solve this. Let's put all the values. Number of electrons in the reaction, that is 2. E naught cell, which is equal to minus 2.303 RT upon F log K equilibrium. Okay, now in the reaction 2.303 RT upon F, it is equal to 0.059. So here we can write E naught cell is equal to 0.059 log K equilibrium, and log K equilibrium is equal to 1 into 10 to the power 20. So we write in 1 into 10 to the power 20 or 10 to the power 20. Okay, so let's try to solve further. So we get E naught cell is equal to 0.059 upon 2 log 10 to the power 20. Log 10 to the power 20. Okay. So here we can write 0.059 upon 2 into 20 log 10. Why? Because log a to the power b is equal to b log a. So we can write 20 log 10. Log 10 value is equal to 1. So we can write 0.059 upon 2 into 20, which is equal to 0.059 into 10, and which is 0.59. So value of E naught cell is 0.59. Now E naught cell, if we talk about E naught cell, so see what is E naught cell over here. E naught cell is oxidation Zn to Zn2 plus. So E naught Zn to Zn2 plus salt bridge, and then reduction Sn2 plus to Sn. So E naught Sn2 plus 2 Sn. So E naught cell comes out to be 0.59. Zn to Zn2 plus. Here in the option Zn2 plus to Zn is given. So Zn to Zn2 plus is going to be 0.76 plus we have to find for Sn to Sn2 plus. So this is minus E naught Sn to Sn2 plus. Okay. So on solving, we get E naught Sn to Sn2 plus as 0.17. 0.17, which we can report as 17 into 10 to the power minus 2. So answer is 17. Clear? That's it. Okay, that's it. Okay. We have already discussed this question, right? Fe3 plus Fe2 plus, the answer is going to be 10, right? Now, let's do next question. The next question is the electrode potential of the following half cell at 298 Kelvin. The electrode potential of the following half cell at 298 Kelvin is dash into 10 to the power minus 2 volt. Up now, if we see this question carefully, so let's write down the information. So at anode, we can write X gives X2 plus 2 electron, and here concentration is 10 to the power minus 3 molar. And at cathode, we can write down Y2 plus 2 electron. It is in Y. It converts to Y solid. And Y2 plus concentration is 10 to the power minus 2 molar. Up now, if I want to write down the complete reaction, so this is going to be X solid, Y2 plus aqueous, and it gives X2 plus aqueous and Y solid. Okay. X2 plus concentration is 10 to the power minus 3, while Y2 plus concentration is 10 to the power minus 2 molar. Now, what we are going to find out? The electrode potential of the following half cell. So, we have to find out the electrode potential. So, E cell we have to find out. E cell we have to find out. So, in order to calculate E cell, first we have to find out E naught cell. How to find out E naught cell? E naught anode. X2 plus. X2 plus. Then salt bridge plus. Then reduction Y2 plus 2Y. So, E naught Y2 plus 2Y. So, X2 plus 2X is minus 2.36. So, X2 plus is 2.36. Now, Y2 plus 2Y is 0.36. So, on solving, what do we get? We get 2.72. 2.72 volt. So, that is for E naught cell. Now, we have to calculate E cell. So, what is E cell? E naught cell minus 2.303 RT upon NF log concentration of X2 plus divided by concentration of Y2 plus. So E naught cell is 2.72. Now 2.303 RT upon F we have to take as 0.06. So let's write 0.06 number of electron 2. X2 plus concentration is 10 to the power minus 3 and Y2 plus concentration is 10 to the power minus 2. So on solving we get 2.72 minus 0.03 log 10 to the power minus 1. On solving further we get 2.76 plus 0.03, which is equal to 2.75, which we can write as 275 into 10 to the power minus 2. So we have to report answer as 275. 275. That is the answer. That is the answer. Now let's do the next question. Which one of the following statement is correct for electrolysis of brine solution? So this is the part of electrolysis. Electrolysis. Brine solution. What is brine solution? Brine solution is NaCl plus water or aqueous solution of NaCl. So what happens? NaCl water on passing electricity. On passing electricity, we get NaOH, Cl2, H2. Okay. So see, NaCl, we have Na plus and Cl minus. NaCl dissociates into Na plus and Cl minus, and H2O gives H plus and OH minus. So Na plus and H plus both goes to cathode. Why? Because cathode is negatively charged electrode, and Cl minus and OH minus both goes to anode. Why? Because anode is positively charged electrode. Positively charged electrode. So now here competition is going to happen. The one which has more standard reduction potential is going to get reduced at cathode, and the one which is more standard oxidation potential is going to get oxidized at anode. Okay, is going to get oxidized at anode. So what happens over here? What happens over here? Anode, we get Cl2. At cathode, we get H2. And then we have NaOH. Na plus combines with OH minus to form NaOH. Now let's find out which statement is correct. Cl2 is formed at a cathode. Cl2 is formed at cathode. No, this is false. O2 is formed at cathode. No, this is also false. Hydrogen is formed at anode. No, hydrogen is formed at cathode. So this is also formed. OH minus is formed at cathode. Yes, this is true. OH minus is formed at cathode, but why? Oxygen is not going to get liberated at cathode, right? Or it's like we have Na plus in the system and OH minus, so they combine, right? It is nearer to the cathode side. So that's what we can understand, right? So answer is going to be the fourth option. Now let's do the next question. So that is based upon the conductance. So resistivity of a 0.8 molar solution of an electrolyte. So concentration, yani molarity. Molarity is what? Concentration, which is equal to 0.8 molar. And resistivity rho, 5 into 10 to the power minus 3 ohm centimeter. And we have to find out molar conductivity. Molar conductivity in terms of 10 to the power 4 ohm inverse centimeter square mole inverse. So when we have to find molar conductivity in centimeters, so obviously we have to use this formula, na? Lambda m is equal to kappa into 1000 upon molarity. So here molarity is going to be in mole per liter and kappa is going to be in centimeter, we can say. Okay? So Simon centimeter inverse. So let's use this formula. So we know that kappa is equal to 1 by rho. So 1 by rho means 1 by 5 into 10 to the power minus 3. So lambda m is equal to kappa into 1000 upon concentration. So kappa is 1 by 5 into 10 to the power minus 3. This is into 1000 and concentration is 0.8, which we can write as 8 into 10 to the power minus 1. So we get 1000 upon 40 into 10 to the power minus 4. 40 into 10 to the power minus 4. So 4 cancel out. So we get 25 into 10 to the power 4. 25 into 10 to the power 4. So the answer is going to be the 25. So you have to report the answer as 25. Okay. Now let's do next question. At what pH given half cell, which is MnO4 minus, right, is converted to Mn2 plus? So Mn2 plus, this is an acidic medium. So changes of 5 electron, then we have to balance oxygen, 4 water molecules. Why? Because here we have 4 oxygen. Then we have to balance hydrogen. So hydrogen balancing, 4 2s are 8. So we have to write 8H plus over here. 8H plus over here, right? So this is how we are going to balance, and this is the half cell reaction. This is what? This is the half cell reaction. So the question says, at what pH given half cell MnO4 minus, which is 0.1 molar, 10 to the power minus 1 molar, gives Mn2 plus, which is 10 to the power minus 3 molar, will have an electrode potential of 1.282 volt. It means E cell is 1.282 volt. And E0 cell is given MnO4 minus up gives Mn2 plus, it is given 1.54 volt. And 2.303 RT by F we have to take as 0.05. So let's use the Nernst equation. We have to find out what pH. So let's do it. So E cell is equal to E0 cell minus 0.059 upon N log Mn2 plus concentration, then divided by concentration of MnO4 minus, and then concentration of H plus to the power 8. H plus to the power 8. Okay, so let's put the value. E cell is 1.282. E naught cell is 1.54, 0.059, N is 5, then log. Mn2 plus concentration is 10 to the power minus 3. MnO4 minus concentration is 10 to the power minus 1. And then concentration of H plus to the power 8. So on solving, we get 1.282 is equal to 1.54 minus 0.059 upon 5, which is log 10 to the power minus 2 divided by H plus 8. We know that log A divided by B is equal to log A minus log B. Okay, so let's expand it. Let's expand it and just solve it. So we get 1.282 minus 1.54 as minus 0.258, minus 0.258, which is equal to 0.059 divided by 5. We get 0.011, no sorry, 118. So this is log 10 to the power minus 2 minus log H plus to the power 8. Okay, H plus to the power 8. It's just we have to solve now. Okay, so let's solve it. Let's solve it. So we get minus 0.258. It is equal to minus 0.0118 minus 2 log 10 minus 8 log H plus. So this is minus 0.258. This is going to be plus 2 into 0.0118. Log 10 is equal to 1. Log 10 is equal to 1. And this is going to be plus 8. Or we can say plus or minus 8 minus log H plus. 8 into 0.0118 and minus log H plus. So minus log H plus is equal to pH. So minus 0.258 plus we get something. ठीक है? And 2 into 0.0118 minus 8 into 0.0118, and this is going to be the pH. This is going to be the pH. ठीक है? So now on solving this, ठीक है, so we get this thing minus 0.2816, it is equal to minus 0.0944 pH. So on solving, pH comes out to be 2.98, which we can write as 3. Which we can write as 3. ठीक है? Which we can write as 3. So the answer is going to be 3. Okay, then let's do next question. 1 into 10 to the power minus 5 molar AgNO3 is added to a 1 liter of saturated solution of AgBr. The conductivity of this solution at 298 Kelvin is dash into 10 to the power minus 8 Simon meter inverse. And Ksp of AgBr is given, and molar conductivity of infinite dilution of respective ions of various ions, they are given. Okay, so how to do this question? So see, AgBr, it is insoluble salt, right? So AgBr solid. If we add water, then we can write Ag plus aqueous and Br minus aqueous. Okay, so if starting solubility is S, so Ag plus ka 0 and Br minus it is 0. But after in time or when equilibrium is achieved, so we can say solid ka to we are not going to write in equilibrium expression, so it is 0 and Ag plus ka S and Br minus ka S. Okay. Now the point is when 1 into 10 to the power minus 5 molar AgNO3 is added. If we add AgNO3, right, so AgNO3 dissociates into Ag plus and NO3 minus, right, NO3 minus AgNO3 dissociates into Ag plus and NO3 minus. So suppose if it is 10 to the power minus 5 molar, at T is equal to 0, it is 10 to the power minus 5 molar. So starting with 0, 0, and then after certain time, we do not have any AgNO3 and we have 10 to the power minus 5 molar Ag plus and 10 to the power minus 5 molar NO3 minus. Okay. Now we know that KSP is what? What is KSP? So KSP is equal to concentration of Ag plus and concentration of Br minus. AgNO3 provides common ion. AgNO3 provides common ion. Ag plus is common ion. So here the concentration is not S, but it is S plus 10 to the power minus 5, which we can write as 10 to the power minus 5. So if I find out the new solubility, now if I say ki S is now S dash, this is the new solubility. New solubility in presence of AgNO3. Then we have to use this formula KSP is equal to concentration of Ag plus and concentration of Br minus to find out the new solubility, right? So let's do it. KSP is 4 point, it is Ag plus and Br minus. KSP is 4.9 into 10 to the power minus 13. S plus ko we can take it as 10 to the power minus 5 and Br minus ka S dash. So S dash or Br minus concentration is going to be 4.9 into 10 to the power minus 13 divided by 10 to the power minus 5. On solving, we get 4.9 into 10 to the power minus 8 molar. Okay. So concentration of Br minus is this. Concentration of Ag plus is 10 to the power minus 5 molar. And concentration of NO3 minus is 10 to the power minus 5 molar. Now, what do we need to find out in the question? We have to find out conductivity of the solution. Conductivity of the solution means we have to find out kappa, right? And molar conductivity, they are given, but everything is in meter, and we have to calculate kappa in meter. So it means which formula we are going to use? We have the formula lambda m is equal to kappa upon 1000 into concentration. If we want to find this kappa in Simon meter inverse, concentration is in mole per liter, and lambda m Simon meter square mole inverse, right? Then we have to use this formula. So for kappa we can say lambda m into 1000 into concentration. So let's use this formula in order to find out conductivity of various ions. So let's find out kappa of Ag plus. So kappa of Ag plus means lambda m of Ag plus. So Ag plus is 6 into 10 to the power minus 3. So it is 6 into 10 to the power minus 3 into 1000 and the concentration is 10 to the power minus 5. Okay, we have to report the answer in terms of 10 to the power minus 8. So I tried to get everything in 10 to the power minus 8. So this is going to be 6000 into 10 to the power minus 8. Now by using this formula, we can find out kappa of NO3 minus, which is equal to lambda of NO3 minus 7 into 10 to the power minus 3. 7 into 10 to the power minus 3 into 1000 into 10 to the power minus 5. So which is equal to 7000 into 10 to the power minus 8. Now kappa of Br minus is equal to lambda of Br minus. So lambda of Br minus is 8 into 10 to the power minus 3. So it is 8 into 10 to the power minus 3 into 1000 and concentration is 4.9 into 10 to the power minus 8. So on solving we get 30 point something, 13 point something, nahi, we get 27, 72 something, so we get 39.2 into 10 to the power minus 8. Okay. Now total kappa is going to be kappa of Ag plus kappa of NO3 minus and kappa of Br minus, conductivity of this. So on summation we get 13039.2 into 10 to the power minus 8. Okay, we get 13039.2 into 10 to the power minus 8. Clear? That's it. That's it. ठीक है? That's it. So this is going to be Simon meter report. So we are going to report the answer in terms of 13039. That's it. Okay. Now let's do next question. The standard electrode potential of M plus and M in aqueous solution does not depend on hydration of gases, and it depends on hydration. It depends on hydration of gaseous metal ion. Why? Because on hydration energy is released. That is called the hydration enthalpy, and if energy is released, then it can basically hamper the potential, or it can change the potential. Okay. Now sublimation of solid metal. Yes, sublimation also changes, or we can say standard electron potential also depends on sublimation of solid metal, because energy is involved. If energy is involved, then electrode potential depends, right? Energy is involved here also. Ionization of solid metal ion, no, because if we talk about the ionization, so it means we have to remove the electron from the metal in the gaseous state, not from the metal in the solid state. So here it is no. And ionization of a gaseous metal ion, so yes. Okay, so the answer is going to be 3. Now let's do the next question. The product which is not obtained during the electrolysis of brine solution, already discussed above, like on brine solution, NaCl water or NaCl aqueous solution. So if we pass electricity, we get NaOH, Cl2 and H2. So answer is going to be 2. HCl is not obtained during the electrolysis of brine solution. Now let's do the next question. So we have the standard reduction potential at 295 Kelvin for the following half cells, right? So the number of metal which will oxidize by NO3 in aqueous solution is. So if you see this reaction, this is the reduction, right? Reduction. So oxidized by NO3 means ki NO3 can oxidize other metal and reduces itself. So these are all reduction potential. So we have to find out that E naught which has negative value or lesser value than this. Negative value or lesser value than 0.97 volt. Why? Because then only that metal can oxidize, right? So here see, this is the negative value, this is the negative value. So yes, it can oxidize. This is also a negative value. Yes, it can oxidize. It can oxidize. This is a positive value but lesser value than 0.97. So yes, it can oxidize. What about gold? It is more, but it has more value in comparison to 0.97, 1.40 volt. So it means this is incorrect. So how many number of metals which will be oxidized by NO3? 3. Okay. So less reduction potential, less reduction potential, and less reduction potential. Okay. Now let's do next question. The reaction occurs in which of the following given galvanic cell? Okay, so just see the reaction. This is the question of the cell representation of the galvanic cell. So see, in this H2 is converted to H plus, and AgCl is converted to Ag. Understood? AgCl is converted to Ag. देखो, H2H plus. So H plus को we can write in terms of HCl, right? So we have to analyze this thing. This is the anode. oxidation, AgCl goes to Ag, so this is cathode, and cathode means reduction. So reduction, Ag plus 1 to Ag0. Okay, so we have to write this thing. Now just try to write the cell representation properly. So this is going to be platinum H2, H plus salt bridge, then AgCl, and then Ag. So if we relate this with the options given below, given above, so answer is going to be 1. Answer is going to be 1. So platinum H2 gas, H plus is from HCl solution. Then we have AgCl solid, AgCl solid, and here also Ag solid. ठीक है? Is it clear? So answer is going to be 1. Now let's do next question. So the specific conductance of 0.0025 molar acetic acid. So concentration is 0.0025 molar acetic acid. So kappa specific conductance is 5 into 10 to the power minus 5 Simon centimeter inverse at a certain temperature. The dissociation constant of acetic acid. So dissociation constant for acetic acid means CH3COH. If we add water, it dissociates into acetate ion and hydronium ion. So suppose at T is equal to 0, we have C concentration, then starting 0, 0, then T is equal to T equilibrium. Because it's a weak acid, so ionic equilibrium concept we have to apply over here. So this is going to be C minus C alpha, this is C alpha, C alpha. Okay, so Ka is equal to C alpha, C1 minus alpha, then we can write C alpha square 1 minus alpha. So we have to find out Ka. So for that we need alpha value. So limiting molar conductivity is given. Infinite M of acetic acid is this 400 Simon centimeter square mole inverse. So first we have to find out lambda M, which is kappa into 1000 upon concentration. So concentration mole per liter, kappa Simon centimeter inverse. Okay, Simon centimeter inverse. So kappa value is 5 into 10 to the power minus 5 into 1000, and concentration is 0.0025. So on solving we get 200 into 10 to the power minus 1, which is equal to 20. Okay. Now in order to find out alpha, so alpha is equal to lambda m upon lambda infinity m. So lambda m is 20 and lambda infinity m is 400. Okay. So it is 400. So we get 1 by 20. 1 by 20. Now let's find out Ka. So Ka is C alpha square 1 minus alpha. So this is 25 into 10 to the power minus 4, because concentration is 0.0025. So we can write 25 into 10 to the power minus 4. Alpha is 1 by 20 into 1 by 20, and 1 minus 1 by 20, which we can write as 19 by 20. So 1 by 20, 1 by 20 upon 19 by 20. So 20 cancel out, and on solving we get 65.7 into 10 to the power minus 7. 65.7 into 10 to the power minus 7, and we have to report the answer in nearest integer. So we can write this is going to be 66. Answer is going to be 66. So 65.7 into 10 to the power minus 7. So we can write 66 into 10 to the power minus 7. That's it. Okay. Now let's do next question. In an electrochemical reaction of lead, at standard temperature, E0 Pb2 plus to Pb is m volt. Okay. And Pb4 plus to Pb is n volt. Fine. So Pb2 plus 2 electron gives Pb. Okay. So E0 value is m volt. Now Pb2 plus gives Pb4 plus 2 electron. So E naught value is, just wait, Pb4 plus 4 electron gives Pb. E naught value is n volt. Fine. We have to calculate E naught value of Pb2 plus to Pb4 plus 2 electron. Okay, fine. So first though, we have to form this equation from these two equations. So let's do it. So see, Pb2 plus is on left hand side. Here Pb2 plus is on left hand side. So there is no need to change the equation number 1. There is no need to change the equation number 1. So equation 1 remains as it is. Pb2 plus 2 electron gives Pb. Now Pb4 plus is on right hand side. So if Pb plus 4 is on right hand side, then it means we have to reverse equation 2. Reverse 2. So if I reverse 2, so we get Pb gives Pb4 plus 4 electron. Okay. So on reversing, E naught value is going to be minus n volt. Minus n volt. Okay. Now we have to add these two equations. On adding these two equations, we get Pb2 plus gives Pb4 plus and 2 electron. So this is the desired equation. This is the desired equation. Now how to solve this question? As E naught is not additive or subtractive, so we have to find out the delta G naught value. Delta G naught value is minus NF E naught cell, because delta G is the extensive property. Extensive. E naught is intensive. So extensive property can be additive or subtractive. Okay. So let's do it. So let's find out delta G naught. So electron minus 2 F E naught for this one is M. Here minus 4 into F and E naught is minus N, which we can write as 4Fn. Now for this one, minus 2 into F and E naught is M minus Xn. M minus Xn. Okay, so finally we can write this is delta G naught 1, this is delta G naught 2, and this is delta G naught 3. So we can say delta G naught 3 is equal to delta G naught 1 plus delta G naught 2, because we have added equation number 1 and 2, right? So delta G naught 1 minus 2Fm delta G naught 2 plus 4Fn, and delta G naught 3 minus 2F M minus Xn. We have to find out the value of X. So on solving, we get minus 2F M minus Xn is equal to, let's take 2F common. So we get minus M plus 2M. Obviously, we have to do the comparison. So what we can write? We can write this as 2F Xn minus M is equal to 2F 2N minus M. So on comparison, X ka value is equal to 2 on comparison. Because here X and here 2, rest is same. So on comparison, X ka value is 2. So the answer is going to be 2. Okay, now let's do the next question. The number of correct statements from the following is. So E cell is an intensive parameter. Yes, E cell is intensive, right? What are intensive parameter? Which do not depend upon the number of moles, right? Number of moles or amount. So E cell is intensive. Yes. A negative E naught means that the redox couple is a stronger reducing agent. Yes, of course. Why? Because if we have the negative standard reduction potential, it means that element does not want to reduce. does not want to get reduced. So they are stronger reducing agent. It means they can reduce other and oxidize itself. So this is correct. Next, the amount of electricity required for oxidation or reduction depends on the stoichiometry of the electrode reaction. Yes, yes. It depends on the stoichiometry. It depends on the stoichiometry. ठीक है? Depends on the stoichiometry. जैसे for example, if we say that Cu2 plus 2 electron, okay, gives 2 copper. So to deposit 1 mole of copper, we require 2 Faraday electricity, na? But if I change the stoichiometry, I am writing 2 Cu2 plus 4 electron gives 2 Cu. So basically to deposit 2 mole, because now we have to deposit 2 mole, na? So here 4 Faraday electricity is required. So yes, the third statement is also true. Now fourth, the amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. Yes, this is Faraday's law, na? This is Faraday's law of electrolysis. Like W is directly proportional to Q. Okay, W is directly proportional to Q. The more amount of charge you are going to pass, the more amount of electricity you are going to pass, then more amount of deposition is going to happen. Understood? So the amount of chemical reaction which occurs at any electrode during electricity by a current is proportional to the quantity of electricity passed through the electrolyte. Yes, it is true. So the answer is going to be 4. The number of correct statement from the following is 4. Now let's do the next question. For lead storage battery, pick the correct statement. During charging of battery, PbSO4 on anode is converted into PbO2. This is statement number 1. So, in order to do this question, we have to know the chemical reaction which is associated with the charging or discharging of the battery. So, generally, discharging reaction is this. Discharging of lead storage battery reaction is this: Pb plus PbO2 in presence of H2SO4 gives PbSO4 plus H2O, basically H2O. Okay, so this is the discharging equation. Now charging equation is the opposite of discharging, so we have to write PbSO4 plus H2O gives Pb plus PbO2 plus H2SO4. Okay, so in discharging what happens? Pb from 0 is oxidized to plus 2. So this is at anode, and Pb from plus 4 is reduced to PbSO4. So this is at cathode. But on charging, reverse reaction is going to happen. So what happens? Pb from plus 2, right, goes to Pb, that is 0 oxidation state. Now this is a reduction, but this happens at anode. And Pb from plus 2 goes to plus 4. Right, this is the oxidation process, but this happens at cathode. Now let's try to find out the answer. So statement number A is, during charging of battery, PbSO4 on anode is converted into PbO2. So during charging of battery, PbSO4 on anode is converted into PbO2. No, it is converted to Pb. So this statement is false. Now let's check the second statement. During charging of battery, PbSO4 on cathode is converted into PbO2. Yes, this is the case. So this is true. Next, lead storage battery consists of grid of lead packed with PbO2 as anode. No, this is false. Why? Because in lead storage battery, anode is lead, and cathode is grid of lead packed with PbO2. So that statement is also false. Now next, lead storage battery has 38% solution of sulfuric acid as an electrolyte. Yes, this is true. So for the electrolyte, we have to use H2SO4 in lead storage battery. So B and D, these are the correct statements. So answer is going to be 4. Okay. Now let's do next question. Okay, a metal surface of 100 centimeter square area, so area is 100 centimeter square, has to be coated with nickel layer of thickness 10 to the power minus 3 millimeter, which is equal to 10 to the power minus 3 into 10 to the power minus 3 meter. 1 millimeter is equal to 10 to the power minus 3 meter, and we have to convert this into centimeter. So 1 meter is 100 centimeter, so it is equal to 10 to the power 2 centimeter. Okay, so on solving, what do we get over here? So minus 3 minus 1, so we get 10 to the power minus 4 centimeter. So that's a length. So now a current of 2 ampere was passed through a solution of nickel nitrate for x second to coat the desired layer. So the value of x is. So this is the question of Faraday's first law of electrolysis. So we know that W is equal to ZIT, and Z is electrochemical equivalent, which is the equivalent weight divided by Faraday into I into T. So we have to find out time. Okay, so mass, how to find out mass? So we have to, density of nickel is given, molar mass of nickel is given. Okay, Faraday value is given. So we know that density is equal to mass upon volume, mass upon volume. So mass is equal to density into volume, density into volume, and it is density into area into length. Okay, so density is 10 gram per ml, or we can say 10 gram per centimeter cube. Area is 100, and length is 10 to the power minus 4. So we get mass in grams, which is equal to 10 to the power 3 into 10 to the power minus 4 gram, which is equal to 10 to the power minus 1 gram. Okay, now we have to find out the value of E equivalent mass. So we have nickel nitrate. So nickel nitrate gives Ni2 plus and 2NO3 minus. So N factor for nickel is equal to 2. So equivalent mass of nickel, it is equal to molar mass divided by N factor. Molar mass of nickel is 60. So 60 divided by 2, it is equal to 30. Okay, now let's put all the values into the formula. So W is equal to E by F, E by F into I into T. So W is 10 to the power minus 1, E is 30, F is 96500, I is 2 ampere, and we have to calculate time, and the time is basically X. So on solving, what do we get? T is equal to 96500 into 10 to the power minus 1, and this is equal to 60. Okay, so we get 9650 upon 60. We get 9650 upon 60. Okay, so on solving, what do we get? So we get 160.8. We get 160.8. So nearest integer mein we are going to write 161 as the answer. So time is equal to 160.8 or 161 seconds. Okay, is it clear? Let's do next question then. Next question. At 298 Kelvin, the standard reduction potential for Cu2 plus to copper, E naught for Cu2 plus to copper, it is equal to 0.34 volt. Given Ksp for copper hydroxide, it is 1 into 10 to the power minus 20. We have to take 2.303 RT as 0.59. Reduction potential at a pH 14. pH 14 means pOH value is 0, because pH plus pOH is equal to 14. So if pOH value is 0, so what we can find out from this? This is minus log of OH minus. So concentration of OH minus, it is equal to minus anti-log of 0. It means 10 to the power 0, which is equal to 1. So concentration of OH minus is 1. And we have to find out the reduction potential for the above reaction. Okay, so let's find out. So we have to use the Nernst equation for this one. So देखो, first of all, copper hydroxide solid, right? If you add water, then copper hydroxide dissociates into copper 2 plus and 2 OH minus aqueous. ठीक है? So KSP is what? Concentration of copper 2 plus and concentration of OH minus का square. So concentration of copper 2 plus is what? KSP upon concentration of OH minus का square, which is equal to KSP, and that is equal to 10 to the power minus 20. Perfect. 10 to the power minus 20. Now why there is need to find out CO2 plus concentration? Because in Nernst equation we are going to use, है ना? In the Nernst equation it is required, because we have to find out the E cell for this one. Cu2 plus 2 electron gives Cu. So E cell for this one is equal to E naught cell minus 0.059 upon 2 log 1 upon concentration of copper 2 plus. So let's put all the values. E naught cell is 0.34. 0.34. So 0.34 minus 0.0592 log 1 upon 10 to the power minus 20. Now let's solve it. So minus 0.34 minus 0.0592, and this becomes log 10 to the power 20, right? It goes in numerator and we have 10 to the power 20. On solving further, we get 0.059 divided by 2, 20 log 10. Log 10 value is 1, right? Log 10 value is 1. So we get 0.34 minus 0.059 upon 2 into 10. Clear? So, sorry, 2 into 20 ko we can write as 0.059 into 10, which is 0.34 minus 0.59. So we get minus 0.25, which we can write as 25 into 10 to the power minus 2. So the value of x is equal to 25. Value of x is equal to 25. So answer is 25 for this question. X का value is 25. Answer. Okay. Okay. Now let's do next question. So the number of correct statements from the following is. So first statement. Conductivity always decreases with decrease in concentration for both strong and weak electrolyte. Yes. On dilution, conductivity increases. Conductivity increases. Specific conductivity is different, right? But if we talk about the conductivity of a particular solution, it always decreases with decrease in concentration. Acha, see what we are going to say. The conductivity is what? Conductivity ko we can write that in kappa na. So that is basically what? In 1 centimeter and in 1 centimeter square. So if you decrease the concentration, or we can say on dilution, what happens? Ions present in 1 centimeter cube volume, right? They are going to decrease, due to which conductivity decreases. So this is going to be true, right? The number of ions per unit volume that carry current in a solution increases on dilution. Number of ions per unit volume that carry current in a solution increases. No, number of ions, they remain same. It's just on dilution the movement is fast. They can easily move from one place to another. So it means this is false. Next, molar conductivity increases with increase in concentration. This is true. This is true. Variation in molar conductivity is different for strong and weak electrolyte. This is also true. For weak electrolyte, the change in molar conductivity with the dilution is due to decrease in degree of dissociation. For weak electrolytes, the change in molar conductivity with dilution is due to decrease in degree of dissociation. No, it is due to increase in degree of dissociation. Dissociation. Because if we have weak electrolyte, suppose CH3COH, so on adding water, it dissociates into CH3CO minus and H3O positive. If you add more amount of water, then what happens? As per the Le-Chatelier principle, reaction moves in the forward direction and we have more amount of ions, right? So this is false. So out of 5 statements, how many are the correct statements? 3 statements. 3 statements are correct. Now let's do the next question. Given that E naught O2 and H2O, it is this and this, right? So the strongest oxidizing agent is, what is oxidizing agent? Which oxidize others and reduces itself. And reduces itself means E naught or standard reduction potential should be high. So it means we have to find out the species which has highest standard reduction potential. So if you see the values, the standard reduction potential is highest for this one. S2O2 minus gives sulfate. Okay, so answer is going to be 3, option number 3. Clear? Now let's do next question. Calculate the standard cell potential in volt of the cell in which of the following reaction takes place. So Fe2 plus Ag plus gives Fe3 plus Ag solid. Okay, perfect. So it means we have to, let's write down the reaction first. So Fe2 plus is converted to Fe3 plus. Fe2 plus is converted to Fe3 plus. So we have to find out standard cell potential. It means E naught cell. Let's write down the cell representation. So Fe2 plus Fe3 plus anode. This is the oxidation. This is the oxidation. And Ag plus 2Ag cathode. And this is the reduction. This is the reduction. So in order to find out E naught cell, we have to write down E naught of Fe2 plus and Fe3 plus salt bridge, right? Salt bridge because Fe2 plus Fe3 plus, then salt bridge, and then Ag plus 2Ag. So E naught Ag plus 2Ag, right? Oxidation, so we have to take oxidation potential, standard oxidation potential. Reduction, so we have to take standard reduction potential over it. So we have to find out the value of this thing. Okay, so Ag plus 2Ag value is already given, x volt. But Fe2 plus 2Fe3 plus value is not given. So we have to find out the E naught value for Fe2 plus 2Fe3 plus from these two. Okay, so let's find out. So Fe2 plus 2 electron, it gives Fe, and here E naught value is Y. E naught value is Y. We need Fe3 plus in right hand side. So I am going to reverse this. So Fe gives Fe3 plus and 3 electron. Okay. So E naught value, we have reversed the equation. So E naught value is going to be minus Z. Okay. Now let's add. So on adding, Fe cancel out and we get Fe2 plus gives Fe3 plus and 1 electron. As we know that E naught cell is the intensive property, it cannot be additive or subtractive, so we have to find out delta G naught, which is equal to minus NF E naught cell. So this is going to be minus 2 because 2 electrons into F into Y, and this is minus 3 into F and minus Z, which is equal to 3FZ. And for this one, minus 1 into F into E naught Fe2 plus 2Fe3 plus, which is the required thing, right? So now on adding, suppose this is delta G naught 3. So delta G naught 3 is equal to minus 2Fy plus 3Fz, and delta G naught 3 is minus F into E naught Fe2 plus 2Fe3 plus. So this is minus 2Fy plus 3Fz. So let's cancel Faraday. ठीक है. So we get E naught Fe2 plus 2Fe3 plus as 2y minus 3z. What do we get? 2y minus 3z. Now let's put this value in the above equation, in this equation. So E naught Fe2 plus Fe3 plus is 2y minus 3z and Ag plus is x. So answer is going to be x plus 2y minus 3z, option number 3. Option 3 is correct. Okay. Now let's do next question. Given in the question, we have some standard reduction potential. Okay, CO3 plus is reduced to CO2 plus, Pb4 plus is reduced to Pb2 plus, Ce4 plus is reduced to Ce3 plus, Bi3 plus is reduced to Bi. So question says oxidizing power of the species will increase in the order. So how to solve this? Oxidizing power means oxidizing agent. And what are oxidizing agent? That oxidize others, and reduces itself, and reduces itself. And reduces itself means the one which has more standard reduction potential is better oxidizing agent. Okay, so we have to find out the standard reduction potential value. So standard reduction potential value is highest for CO3 plus. CO3 plus. So highest is for CO3 plus, then Pb4 plus, then Ce4 plus, and then Bi3 plus. ठीक है? So value decreases in this order. Okay, so we have oxidizing power of the species will increase in the order. So in increasing order, option number 2 is the correct answer. Option number 2 is the correct answer. Now let's do the next question. For the cell, zinc solid gives Zn2 plus aqueous and Mx aqueous gives M solid. Different half cells and their standard electrode potentials are given. So which cathode will give a maximum value of E naught cell per electron transfer? So अब C per electron transferred है, E naught cell is intensive, either for 1 electron, either for half electron, 2, 3, whatever. Okay, so it means which cathode will give a maximum value of E naught cell. So if I write the cell representation, so this is going to be Zn and Zn2 plus, and this is going to be Mx plus and then M. So E cell is equal to E naught of Zn, Zn2 plus. In place of salt bridge, just add addition sign, plus sign, and then E naught Mx plus 2M. E naught Zn2 plus to Zn is given, zinc is given, that is minus 0.76 volt. But we have to take the standard oxidation potential, so this is going to be 0.76 volt. Okay, plus E naught Mx plus M. So which cathode will give a maximum value of E naught cell? So obviously we have to find out the highest value for this one. Then only E naught cell is going to be maximum. So highest value for E naught is for this one, 1.040. So 0.76 plus 1.40, 0.76 plus 1.40, so we get the maximum value. Okay, rest values are 0.80, 0.71, minus 0.44. So obviously we do not get the maximum value. So answer is going to be option number 3. Answer is going to be option number 3. Now let's do next question. Given that standard potential of Cu2 plus to Cu and Cu plus to Cu are 0.34 and 0.522 volt respectively, we have to find out E naught for Cu2 plus to Cu plus. How to do this? Obviously what we are going to do, we have to find out the delta G naught values, right? So just for example, we have Cu2 plus 2 electron and Cu, right? So here we have to find delta G naught. Then we have we need Cu plus in the right hand side. So it means we can write Cu gives Cu plus electron, and here we can find out, suppose this is delta G naught 1, here delta G naught 2, and then we have to add in order to calculate delta G naught 3. So basically you have to use that one, delta G naught 3 is equal to delta G naught 1 plus delta G naught 2, and delta G naught you can write as minus NF E naught cell. So when you solve this, you get the answer number 2. So just try to solve on your own, you get the correct answer. Okay, that's it. Now let's do the next question. An oxidation reduction reaction in which 3 electrons are transferred has a delta G naught of this one at 25 degrees Celsius. The value of E naught cell is dash. So N is equal to 3 over here. Delta G naught is minus NF E naught cell. So we have to take delta G naught in joules. So 17.37 into 10 to the power 3 joules. N is 3, Faraday is 96500, and we have to find out E naught cell value. So on solving E naught cell value, what do we get? We get minus 17.37 into 10 to the power 3 divided by 3 into 96500. So on solving you get minus 0.06, which we can write as 6 into 10 to the power minus 2, right? So answer is going to be 6. So you have to report the answer as 6. Now let's do the next question. For the reaction 2Fe3 plus aqueous plus 2I minus aqueous gives 2Fe2 plus aqueous plus I2 solid. The magnitude of standard molar free energy change. How to do this question? So in order to do this question, we have to use this formula only. Delta G naught is equal to minus NF E naught cell, and in order to calculate E naught cell, we should be having this value. Which value? Fe3 plus Fe2 plus. This is the reduction process, and I minus 2I2, this is the oxidation process. So we should be having this value na, E naught of I minus 2I2 plus then E naught of Fe3 plus 2Fe2 plus. So E naught I minus 2I2, right? These information that should be given to you. So let me write all this information. So E naught Fe2 plus 2Fe, it is equal to minus 0.440 volt. E naught Fe3 plus 2Fe is equal to minus 0.036 volt, and E naught I2 to 2I minus, it is equal to 0.539 volt, and Faraday value you have to take as 96500 coulomb. Okay, so I minus 2 I2 value is given. I minus 2 I2 value is given now. So this is going to be minus 0.539. This is going to be minus 0.539 I minus 2 I2 value. Okay, and then what you need to do, you have to find out the value of this by using these two equations, right? Using these two equations you can get the value of this, and then you have to put E naught value into this formula. Delta G naught is equal to minus NF E naught cell. So on solving, what do you get? You will get 45 as the answer. So please try on your own, right? Just try on your own. We have discussed similar type of question many times. Okay, now let's do this question. The standard Gibbs free energy for the given cell reaction in kilojoule per mole at 298 Kelvin is, it means you have to find out standard Gibbs free energy. E naught value is given, so it means you have to use this minus NF E naught cell bete. So N क्या होगा? N number of electron, that is equal to 2. Number of electron is equal to 2, right? And Faraday is 96,000 over here, and E naught cell value is 2. So which is equal to minus 4 into 96,000 joule. But we have to find out the answer in kilojoule. So I can write minus 4 into 96 into 10 to the power 3 joule, which is equal to minus 384 kilojoule. So answer is Option number 1, minus 384 kilojoule. Okay. Now, next question. The Gibbs energy change for the given reaction at this Cu2 plus concentration is equal to Sn2 plus concentration, which is equal to 1 molar. And we have to find out the Gibbs energy change. Gibbs energy change means we have to use this formula. Delta G is equal to delta G naught plus 2.303 RT log Q. So we have to find out this. So delta G naught को we can find out by minus NF E naught cell plus 2.303 RT, and in place of Q we are going to write copper 2 plus concentration divided by Sn2 plus concentration, right? Let me rewrite this. So delta G is equal to delta G naught plus 2.303 RT log concentration of copper 2 plus divided by concentration of Sn2 plus, right or wrong? Okay, so copper 2 plus concentration and Sn2 plus concentration is 1. So we can say that delta G is equal to delta G naught. Okay, because log 1 is 0, right? Here we have log 1 upon 1, which is actually equal to 0. So delta G naught is minus NF E naught cell. So two electrons, they are going to exchange, right? So here we have minus 2 into F का value 96500 and E naught cell. So E naught cell is E naught copper to copper 2 plus E naught Sn2 plus 2Sn. Okay, so copper to copper 2 plus is equal to minus 0.34 and Sn2 plus 2Sn, it is minus 0.16, which is equal to minus 0.5 volt. Okay, which is equal to minus 0.5 volt. So delta G is equal to minus 2 into 96500, and E naught cell is minus 0.5, which is equal to 1 into 96500 joule. So answer is 96500 joule, and if it is asked in kilojoule, so you can write 965 kilojoule. Okay, now let's do the next question. For a reaction Mn plus and Mn plus 1 accepts an electron to give M plus. The Nernst equation. So how to write the Nernst equation? E is equal to E naught minus RT by NF ln concentration of M plus, because ion है, and here concentration of M to the power n plus 1. Okay, clear? So that's it. So what is correct? Option number B is correct. If I want to write this in terms of log, so E is equal to E naught minus 2.303 RT by NF log concentration of M plus upon concentration of Mn plus 1. Okay, now let's do next question. Given the equilibrium constant, that is equal to 10 into 10 to the power 15, calculate the E naught cell of this reaction. So we have to calculate E naught cell. So how to calculate? Delta G naught is equal to minus 2.303 RT log Kc, and in place of delta G naught I can put minus NF E naught cell, which is minus 2.303 RT log Kc. Now let's solve. N ka value is 2 from the equation. Here 2Ag plus gives 2Ag, Cu gives Cu2 plus. So N ka value is 2 over here. So E naught cell is equal to 2.303 RT by F into 1 by 2, because N ka value is 2, and log Kc. So Kc is 10 into 10 to the power 15, which is equal to 10 to the power 16. So in place of 2.303 RT by F, we have to put 0.059 upon 2, and this is going to be 16, right? This is going to be 0.059 upon 2 into 16 log 10, which is 0.059 into 8. So on solving, you get 0.472 around. So if we see the options, so the closer option is option number 3. So option number 3 is the correct option. Now let's do the next question. EMF of the following cell at 298 Kelvin in volt is x into 10 to the power minus 2. So we have this reaction. The value of x we have to find out. It means you have to find out E cell. So what you need to do? You have to use the Nernst equation, E naught cell minus 0.059. So electron 2 log concentration of Zn2 plus upon concentration of Ag plus ka square. Why Ag plus ka square? Because if we write the complete equation, so zinc gives zinc 2 plus 2 electron and Ag plus accepts 1 electron and converts to Ag. So obviously below equation ko we have to multiply by 2. So when we multiply by 2, so we get overall equation as zinc plus 2 Ag plus gives 2 Ag plus Zn2 plus. Okay, so that's why we have to do this. Now the question is simple. Question is simple, right? You have to put all the values and solve it. And when you solve it, so you get E cell is equal to 147 into 10 to the power minus 2. Just try to solve on your own, right? And answer is 147. Okay, just try to solve. It's just you have to put all the values which are given in the question in this equation. That's the last equation. Okay, now let's do the next question. Okay, so this is for the disproportionation reaction. The disproportionation reaction means single element exists in 3 oxidation state. In the reactant side we have only 1 oxidation state, and in the product side we have the element in 2 oxidation state. So we can write the equation as Cu plus Cu plus. It is in equilibrium with Cu plus Cu2 plus. So if we talk about the anode, so anode means Cu plus to Cu2 plus. So this is anode, and anode means oxidation. Okay, now Cu plus to Cu, so this reaction occurs at cathode, and cathode means reduction. Okay, cathode means reduction. Now what to do? We have to find out ln K. We have to find out the value of ln K. Okay, so E naught cell is equal to, or we can say that, see, for the disproportional reaction is this, where K is the equilibrium constant, ln K. So we have to find out the value of ln K. So how to find out the value of ln K? So we know that delta G naught is equal to minus RT ln K. Okay, I'm not writing in terms of log because in the question we have to find out the value of ln, natural log. So delta G naught NF E naught cell, which is equal to minus RT by ln K. So ln K is equal to NF E naught cell upon RT. Okay, so RT by F का value is 0.025. RT by F का value is 0.025. Okay, so see, if we see the change of electron, so here we have change of 1 electron and here we have the change of 1 electron. So this is going to be 1 into E naught cell upon 0.025. Now let's find out the value of E naught cell. So E naught cell, it means standard oxidation potential at anode plus cathode standard reduction potential. So standard oxidation potential anode Cu plus to Cu2 plus. Cu plus to Cu2 plus, so which is equal to minus 0.16. Reduction potential Cu plus to Cu 0.52. So 0.52, so when you solve this you get 0.364. So just find out the value for ln K. So ln K is equal to 0.0 ठीक है, So 1 into E naught cell divided by 0.025. So when you solve this, you get एक minute, just check my calculation. Just check my calculation. So what is the value of this one? 0.52 minus 0.16. This is 0.36. Okay, fine. So E naught cell is going to be fine. So this is going to be 0.36 into 1 upon 0.025. So when you solve that, you get 144 into 10 to the power minus 1. So answer is going to be 144. Answer is going to be 144. That's it. Now let's do next question. So see, this question is also based on the Nernst equation, right? So you have to find out the ratio. We have discussed a similar type of question, right, in this lecture only. So use Nernst equation. Just try to use Nernst equation, and when you solve, you will get the answer as 2.15, which is equivalent to 2. Okay, just try. Just try on your own. Okay. Now let's do next question. If the standard electrode potential for a cell is 2 volt, E naught cell is 2 volt at temperature 300 Kelvin. So we have to find out equilibrium constant. Okay. N ka value is 2. Just see the reaction. N ka value is 2. Z into Zn2 plus 2 electron change, and Cu2 plus 2 Cu2 electron change. Okay, fine. But we have answer in terms of e to the power. It means we have to take natural log, right? We have to take natural log. So what is delta G naught? So delta G naught is minus RT ln K equilibrium, and delta G naught I can write minus NF E naught cell is equal to minus RT ln K equilibrium. So ln K equilibrium is going to be minus NF E naught cell upon RT. So let's put the value. So that is minus 2 into 96500. 2F E naught cell is 2 and divided by RT. R ka value we have to take as 8 and temperature is 300. So 8 into 300. So on solving, what do we get? We get around 160. 160.8 we get. Okay? So that is the ln K. ln K equilibrium. So answer is going to be, if I want to find K equilibrium, so if I want to find K equilibrium, so K equilibrium is going to be bete e to the power 160.8. And if we see the option, then option number 4 is the correct one. Option number 4 is the correct one. Okay, now let's do the next question. Okay, fine. So let's do this. Platinum H2 gas 1 bar HCl. So this is anode, okay, and this is cathode. So let's write down the reaction. So here we can say H2 gives 2H plus 2 electron, or we can say that H2 gives H plus, half H2 gives H plus 1 electron. Now we have AgCl, so AgCl accepts 1 electron and we get Ag plus and Cl minus. Ag plus and Cl minus. Not Ag plus, we get Ag solid and Cl minus. Okay, and this is AgCl. Okay, fine. So overall reaction is AgCl plus half H2, then Ag solid, Cl minus, and then H plus. Fine. So let's try to do this. So we have to find out what cell potential is 0.92, and we have to find out standard electrode potential of AgCl. So देखो E naught cell is what? E naught cell is E naught H2H plus E naught AgCl 2Ag. Understood? AgCl2Ag and Cl minus. AgCl2Ag and Cl minus. Just give me a moment. Just give me a moment. AgCl2Ag and Cl minus. So E naught H2H plus is 0. So E naught cell is equal to E naught AgCl Ag and Cl minus. So how to do this? We have to use the Nernst equation. E cell is equal to E naught cell minus 2.303 RT by NF. NF 1F. So 1 into F log concentration of Cl minus and concentration of H plus. Cl minus concentration of H plus and here pressure of H2. Pressure of H2 का power half. So E cell का value is 0.92. Okay, 0.92. So we have to find E naught cell. Now 2.303 RT by F is 0.06 at 298 Kelvin. So let's take it. So 0.06. So log 10 to the power minus 6 molar HCl. ठीक है, 10 to the power minus 6. So here we can say it is 10 to the power minus 6, it is 10 to the power minus 6, and this is 1. Okay, so this is 0.92 is equal to E naught cell minus 0.06 log 10 to the power minus 12, log 10 to the power minus 12, log 10 to the power minus 12. So when you solve this, so you get E naught cell ka value is 0.20 volt. 0.20 volt. So answer is going to be 4. Answer is going to be 4. Clear? That's it. What would be the electrode potential for the given half cell reaction at pH 5? So pH 5 means concentration of H plus is equal to 10 to the power minus 5, because we know that pH is minus log of concentration of H plus, and concentration of H plus is going to be minus anti-log of pH. Okay, so in the question we have 2H2O gives O2 plus 4H plus 4 electron. So this is the reaction of oxidation, right? And E naught reduction is given, which is 1.234. So we have to write down the E naught of oxidation. So E naught of oxidation is going to be minus 1.23 volt. Now what we are going to do over here, we have to find out E cell. So E cell is equal to E naught cell minus 0.059 number of electrons which are exchanged equal to 4, and then log concentration of H plus to the power 4 and pressure of O2. Now E naught oxidation is minus 1.23 minus 0.059 upon 4, and this is going to be 4, or we can say H plus concentration is, what is the H plus concentration? 10 to the power minus 5. So log 10 to the power minus 5, 4, and pressure of O2 is 1. So it means on solving, what do we get? Minus 1.23 minus 0.0594, and this is log of 10 to the power minus 20, which gives this minus 20 log 10. Okay, so minus 1.23 plus 5 into 0.059. So once you solve, you get 0.935 as the answer. So 0.935 is the answer. Now let's do the last question for this lecture. So the question says the magnitude of the change in oxidizing power of the MnO4 minus gives Mn2 plus couple is itna. If the H plus concentration is decreased from 1 molar to 10 to the power minus 4 molar at 25 degrees Celsius. So we have to find out the value of X over here. So first let's write down this reaction. So MnO4 minus takes 5 electron and converts to Mn2 plus. Now we have to balance what? Oxygen. So 4 oxygen. So in the product side we write 4 water molecules. Then we have 8 H plus. So in the reactant side we write 8 H plus. So this is the balanced reaction. Okay, balanced half cell reaction. Now E cell is going to be the E naught cell minus 0.059 upon 5 log of concentration Mn2 plus divided by concentration of MnO4 minus and concentration of let me rewrite this. So this is log of concentration of Mn2 plus upon concentration of MnO4 minus into 1 by concentration of H plus to the power 8. Okay, so this is the normal equation, general equation. Now I am going to put the value of H plus. So from H plus is decreased from 1 molar to 10 to the power minus 4 molar. And we have to find out the change in oxidation, right? Basically change in oxidizing power. So E1 is going to be the E naught cell minus 0.059 upon 5 log concentration of Mn2 plus upon concentration of MnO4 minus, and here 1 by 1 to the power 8. 1 by 1 to the power 8. So this is equation number 1. Now E2 is E naught cell minus 0.059 upon 5 log of concentration Mn2 plus and concentration of MnO4 minus, and now H plus concentration is 10 to the power minus 4. So this is 1 upon 10 to the power minus 4, 8. So on solving this, we get E naught cell E2 as E naught cell minus 0.059 log concentration of Mn2 plus upon concentration of MnO4 minus into 10 to the power 32, right? So this is the equation number 2 into 10 to the power 32. This is equation number 2. Now what we are going to do? Minus. We have to minus E1 minus E2. So once you minus E1 minus E2, so see, cancel, cancel. ठीक है? Cancel, cancel. Now we have to take 0.059 upon 5 common. Common. ठीक है? Log Mn2 plus MnO4 minus log Mn2 plus MnO4 minus cancel out. Cancel out. And then we have log 1 0. ये तो complete 0 है. And then we have 32. So this is going to be into 32 log 10. 32 log 10. ठीक है? So 32 log 10 हुआ. So on solving we get 3776 into 10 to the power minus 4. Okay. So students, this is the last question for this video lecture. We have some more question in this file, so you have to try on your own. I will write the answers and then you can check your answers, and if you are having any doubt, if you face any kind of difficulty, then we will discuss in the class itself. Okay, so bye everyone. Hope you understood the lecture. Hope you understood all the questions completely. Bye, take care.